Good evening. In this video, we are going to talk about proposition 21 from book 1. Okay, so this proposition declares that given a triangle, and if we construct two straight lines with the same extremity as a side, and they meet with each other inside of the triangle, then the sum of these two straight lines will be less than the sum of the other two sides, but the angle contained by these two straight lines will be greater than the angle contained by those two other sides. Okay, for example, this is a triangle ABC, and we have a side AB with extremities point A and point B, and then we can construct two straight lines AD and BD meet with each other at point D inside of this triangle ABC. So the proposition declares that we have ADE plus BD, it is less than the sum of other two sides, which are AC and BC, and the angle here is greater than this angle. So the angle contained by these two straight lines, which is angle D, it is greater than the angle contained by the two other sides, which is angle C. Okay, this is greater than this. Let's give it a proof. So as a first step, please recall postulate 2, that we are able to produce a straight line. So let's produce AD, and let's assume it meets the side BC at the point of E. Okay, so please recall proposition 20. In a triangle, the sum of any two sides will be greater than the third side. Okay, so at first, pay attention to this triangle AEC. The two sides AC and CE, the sum of them will be greater than the other side AE. So we have this inequality, CA plus CE will be greater than AE, right? And let us add the same thing to the two sides of this inequality. Let us add BE here. So AE plus CE plus BE will be greater than AE plus BE, right? And this is equal to CA plus CB, right? So this is a sum of two sides of the original triangle ABC. And and please pay attention to this triangle BDE. And if we apply the same proposition, we have this inequality that BE plus DE will be greater than BD, right? So this side plus this side will be greater than the third side. And similarly, let us add the same thing to both sides of this triangle. In this time, we add AD. So BE plus AD plus DE will be greater than BD plus AD, right? And this equals to BA equals to BE plus AE, right? And please pay attention to these two inequalities. If we combine them together, we can find that, first of all, CA plus CB, the sum of the two the original triangle's two sides, it is greater than AE plus BE, AE plus BE, these two sides. And meanwhile, AE plus BE, it is greater than BD plus AD. BD plus AD is here. BD, AD. this is the two straight lines we constructed. So we know that combine them, we can say that CA plus CB is much greater than BD plus AD, right? BD plus AD, which proves our first statement. So this is smaller than that, right? And in the next part, let's try to prove the relationship between these two angles. Okay, so please recall proposition 16. So the exterior angle of any triangle will be greater than any of the opposite interior angle, right? So let us pay attention to this triangle BDE. What we can conclude that this angle, let's say ADB, this is the exterior angle of this triangle BDE, and is greater than the opposite interior angle. So we know that it is greater than angle DEB, right? And again, pay attention to this triangle ACE, where this is an exterior angle. So apply proposition 16 again, we can conclude that angle DEB is greater than the opposite interior angle, which is angle C. So let us combine these two inequalities together again. What we can conclude, so this is greater than this, and this is greater than this, which means angle ADB is much greater than angle C. So we can conclude that angle ADB is greater than angle C, which proves the second statement of this proposition. So this ends our proof. And in the next video, we are going to talk about proposition 22. Thanks for watching. Have a good day.